Hello students, in this video we are going to learn about laws of exponents. So there are some laws which we have to know before doing exponents. See, there are two cases that our power can be positive or our power can be negative or zero. So first we will read about case first. Case first, that is when power is positive. Only about that we will learn first. So power is positive, or we can say positive integral exponents, means in which the exponents are positive. So case first can be if two numbers are first law in this is if two numbers are like one number is a and again one number is b, a again, and having different power. See, like a is having power 3 and again a is having power 2. So how we can write? You can write it as a to the power 3 plus 2 5. You can write it like this, means we can take here power at the place of 3 and 2, m and n, two variables. So a to the power m into a to the power n will be always equal to, if base are same, condition is that if base are same, so what it will be equal to, base will remain same only and power we will add m plus n. Some example we can take, like if it is 2 to the power 3 into 2 to the power 5. So what will be our answer? See, same bases are, so base we will write as it is and power we will add. In multiply only it will happen. So 5 plus 3, 6, 7, 8. It will be 2 to the power 8. Same way, if I will write 7 to the power 2 into 7 to the power 3. 7 to the power 7. So what will be our answer? So base are same, they are in multiply, so we will write base same as it is, then power we will add 7 plus 2. We will write here 7 plus 2. So it will be 7 to the power 7, 8, 9. So this is our first law of exponent. Now come to the second law, that is if law second says if a number is like this, a to the power m to the power n. See, here you can see, here is a to the power m bracket to the power n. So what we can write it as? We can write it as a, base will remain same, and this power we can multiply. You know that bracket means multiply, so this will be multiplied here. So it will become m into n, where m and n are any numbers, positive integers, because we are reading here positive only. It can be negative also, that case will be little different. See, example we can take, like if it is 2 to the power 2 bracket to the power 2. So what will be our result? We can write 2 as it is base and 2 into 2, means we will multiply it together, 2 to the 4. So 2 to the power 4 will be our answer. Whatever the value will be, that will be our answer. Same way, if it is 4 to the power 3 bracket to the power 2. So what will be our answer? We will multiply these two. 3 to the 6. So 4 to the power 6 will be our answer. In the same way, third law is, it says if it is a b to the power n, so it will be equal to a to the power n dot b to the power n. See, what does it mean? If a number is like ab means it can be any rational number. A can be any rational number, b can be another rational number other than a. So it will be equal to a to the power n, means whatever the power will be, dot b to the power n. So how we can understand it? Just see here, like it is written 2 into 3 to the power 4. So how we can write it is separately. See, 2 into 3 it is written to the power 4, means it will be 2's power will be 4 and again 3's power will be 4 also. Separately we can write it as 2 to the power 4 into, means bracket or dot we can put 4 into, and 3 to the power 4. It is the same, no? If we are writing 2 into 3 to the power 4 is equal to 2 to the power 4 into 3 to the power 4. Same way, if we are writing 7 into 3 to the power 6, so it will be equal to 7 to the power 6 into 3 to the power 6. 7 to the power 6 into 3 to the power 6. This dot is a simple symbol for multiplication. So I hope it is clear that what is our third law. Means a b to the power n is equal to a to the power n dot b to the power n. Now come to next, that is in division. See, up to now we have learned about the cases in multiplication, here also, and here also. Now come to division. If in division cases, like here I can write. See, same way in division what will be here, if base is same, a to the power here 3 was 3, same we are writing, divided by a to the power 2. So what we will do, you can see base are same. So in multiplication what we have done, we added the power. So in division what we will do, we will subtract the power. So a to the power, base will remain same only. Here also, no? In multiplication you can see a to the power m into a to the power n is equal to a to the power m plus n. So in division it will be a to the power, we will subtract here 3 minus 2. It will be equal to 3 minus 2 means 1. It will be a to the power 1 means a only. It will be a to the power 1, or you can simply write it as a. So in symbolically how we will write, we can write it as a to the power m divided by a to the power n, or you can also write it as a to the power m divided by a to the power n. Like this also you can write, or like this also you can write. So it will be equal to base, if same bases are, this is the case when base are same. If base are different, then we can't apply these laws. Base should be same. So base is same, a. So in division there, so what we can write, a to the power m minus n. This you will remember. Same way, a to the power m minus n we can write. So one example we can take, like it is written 2 to the power 5 divided by 2 to the power 3. So what will be our answer? You know that base will remain same, and what we will do in division, that power will get subtracted. So 5 minus 3 we will write here. So it will be equal to 2 to the power 5 minus 3 is 2. So 2 to the power 2 will be our answer. In the same way, if it is 7 to the power 6 divided by 7 to the power 2. So what will be our answer? You can write, or like this also we can write, na, 7 to the power 2. So what will be our answer? You know that base will remain same 7 we will write, and power we will subtract. So 6 minus 2. So it will be equal to 7 to the power 4. This will be our answer. Now next case is if m is equal to n. If m is, this is the case that this will be applied for all. Now some special cases we will take in this. Suppose m is equal to n. Here you know that power is m and n. M is equal to n. So what will happen? A to the power m upon a to the power n we can write. Now m is equal to n means we can write a to the power m upon, at the place of n we can write m because both are equal. So a to the power m. So after cancelling it out, our result will be 1 only. Means it is a special case of that a division of exponents, that if m is equal to n. Or one case you know that if m is greater than n, means here you can see, na, all that m is greater, that upper power, that number which is in numerator having greater power, that you can see all these cases are that we have done before. And third case can be if m is less than n. So what will be there? Just see here, like 2 to the power 2 I am writing, it is divided by 2 to the power 4. Now you can see here, this is m, this is n. Now which one is greater? N is greater, means the number by which we are dividing, that having greater power. So what it will be? See, we can write it as base will remain same only 2, and power we will subtract. So 2 minus 4 we will do. So what will be our value? You can see here negative number is greater. So minus 4 plus 2, it will be equal to 2 to the power minus 2. Now what you know that we were reading about power case first, that is power is positive only. So now you can see here little bit difference is there, that negative power came here. So how we will solve negative powers? This is our case second. Case second, that is power is negative. So you will see here, if power is negative, like in this you can see our result is, if when it will be, when in division it will be that second power, that case is this one. You can see here, when n is greater than m, then only it can be the. So if n is greater than m, suppose some example I am taking, say 5 to the power 5 divided by 5 to the power 8. Here you can see n is greater, this is m, this is n. So n is greater, so what will be our result? It will be base same as it is, and power we will subtract. So 5 minus 8 we will do. So you know that negative number having, greater number having negative power. So 5 to the power 5, 6, 7, 8 minus 3 it will be. So how we can write this negative power? This we can represent as, see, whenever power is negative we will put it in denominator, that 1 upon 5 to the power 3. So we can write this 5 to the power minus 3 as 1 upon 5 to the power 3, or we can represent it like this. Or if a number is like 2 to the power minus 8, what does it mean? It means we can write it as 1 upon 2 to the power 8, or simply we can write as 1 upon 2 to the whole to the power 8. Why? Because you know that it is in denominator, when it will come up its power will be negative. So if we want to write like 1 upon 5 to the power 3, if I want to write this 5 up or this 5 in numerator, so how we can write? We can write it as, you know that it is same as 1 upon 5 to the power 3. It is in denominator, so making it in numerator or in single line. So what we will write? 5 to the power minus 3. We know no, that negative power means, here you can see negative power means it will come in denominator. So same way, if it is in denominator, if we are writing it in numerator, then it will be have negative power, or index will be negative. One more case is when power is 0. These are some special cases in this, that if power is 0. If power is 0, then what will be the value? See, always you will remember, if any digit is like 100 or 1000 to the power 0. So whenever any digit is any number is having power 0, its value will be always 1. If I will write a to the power naught or a to the power 0, then what will be its value? Its value will be always 1. So this you will remember, if a number is having 0 power, it means it will be always equal to 1. Or if a number is having negative power, like a to the power minus 8, so it means it will be equal to 1 upon a to the power 8. These things you will remember. In this way you can solve the whole exercise. Thank you.